Hello students, this is the 2A lesson recording for motion and acceleration. Alright, so this is a reminder that this is my contact information up here, email and phone number, and please remember that you do get 3 attempts on every assignment. You'll remember that on Thursday we had the 1D lab report, which is currently worth 60% of your grade because it is the only assignment in your lab and exams category. So it's worth a huge amount, so please make sure you get it done. It will be graded over the weekend. And remember, if you don't do well on it the first time, you can always submit it again because again, you do get 3 attempts. We are on day 5, and today we have our topic motion and acceleration. You'll be completing the 2A notes, as well as you will have an extra credit discussion, which you can look for in your course. All right, so this is a quick reminder that your grades tab does have everything that you need in order to be successful. So I can show you what that looks like again. Give me one moment to pull that up. All right, so if we're looking right here, we should be able to see that this is what your grades tab looks like. So for example, it has the information on STAR 360, which is worth 200 points, 10% of your grade. So instructions are here, the website, how you get your username and password is all there as well as everything else you need. So links to, for example, to the 1D recording, which again goes over every single answer and step for the 1D lab report, which is 60% of your grade, as well as links to notes and reminders about attendance. So your grades tab is very important. Make sure that you are checking it frequently. And again, this lab report category is 60%, and there's currently only 1 assignment in it. So you need to make sure you do it well, because it's going to count for 60% of your grade. If you don't do it, you'll notice that you will never be able to have a passing grade because the rest of your grade is only worth 40%. STAR attendance notes are only worth 40% of your grade. Okay, so we are starting our next unit, which is all about forces in motion. So we'll be taking a look at the 3 different laws of motion at the end of the unit, and we'll be demonstrating those. Today we're going to learn a little bit about just what motion is in general, as well as acceleration. So our objectives are to understand the differences between speed and velocity, be able to define and calculate velocity, and then also be able to calculate and describe the effects of acceleration on velocity. So again, you should be completing the 2A notes during this session, during this lesson. I'll go ahead and show you how to do that in just a moment. But here's our agenda. We're going to talk a little bit about motion, speed, and velocity, learn how to calculate velocity, and then apply it. We'll talk about the types of acceleration, learn how to calculate acceleration, apply it, and then review our objectives and reflect on our learning. So at this point, you want to open up your notes if you don't have them open already. So if you are getting to this manually, you can go ahead and do this from the Content tab. I do recommend, again, if you're in your Grades tab, it'll be right here under 2A Notes. But if not, you can go to Content and then scroll down to Unit 2 on the left. And then if you scroll down, you'll find the 2A notes right here. So you can click 2A notes, and then when you look at it, it won't look like this. It'll actually look like this. And you can go ahead and click Start. So you'll click Start Quiz, and that will open it up for you. So open up your 2A notes, and again, you don't need to do anything with it yet. I will be giving you all of the answers as we go through class. So I try to remind you many times, all the answers are in the recording. You don't need to know any of the answers. You just need to follow along with the lesson, and we're going to go over the answers together. Okay. All right. So here we go. We're going to talk a little bit about describing and measuring motion. So velocity describes which way motion goes, the direction of it, as well as describing the speed of motion. So we're going to take a look at what that looks like. So motion describes how an object moves from one position or location to another. So how you get from A to B. Now, when we talk about motion, oftentimes we talk about how fast you're moving, and in that case, that is speed. So speed is how fast an object changes position. Let me grab my point right here. So it's how fast an object changes position, and we measure this in distance per time. So the one that you're probably most familiar with is the one that's on your car speedometer, and it's called a speedometer because it's speed, so it's measuring speed, and we measure that in miles per hour. So the distance would be the miles, and then the hour would be the time. But in our class, we're going to actually be using more often meters per second, because remember, meters is a part of the metric system, and that is the scientific system of measurement that we use in our class. So we're going to be doing meters per second. And the important thing about speed is that for speed, direction does not matter. So whether or not you're going forward in a car or you're going in reverse in a car, the speedometer will show will still show the same speed, right? So if you're going forward at 30 miles per hour, or you are going in reverse at 30 miles per hour, the speedometer, no matter what, will still show exactly 30 miles per hour. So the direction of your car does not matter. Velocity, on the other hand, is a little bit different. So velocity still shows how fast an object is going, but it also includes direction. So velocity shows both speed and the direction of the object. So in this case, now we get into positives and negatives, because you could say that an object is moving 3 meters per second to the right, and going to the right would be the positive direction. So you could say positive 3 meters per second. Or you could say that it's going to the left. And if you said left, then that would be the negative direction. So you would actually need to include a negative 3 meters per second. So again, your car does not show velocity because your car does not have negatives on its speedometer. So speed only cares about how fast. Velocity includes this idea of direction. So in order to calculate velocity, there's a few things that we need to know. We need to know the distance that the object traveled, and we also need to know the amount of time that the object traveled, which should make sense, right? When you're figuring out how fast your car is moving, you want to figure out how fast does it get from A to B, and or how far is A to B, as well as how long it took you to get there. So if you're going to your friend's house, if it took you 10 minutes to get there, that's going to show you what your velocity is, how fast you got there. Okay, so velocity, the equation for it is going to be the distance that you traveled divided by the amount of time it took you to travel. So distance divided by time. So in your notes, you'll notice that you have this exact sentence here. So in the blank, you should fill in the word calculate. Go ahead, pause the video, fill in the word calculate, and then continue playing once you're ready. Okay, so we're going to actually go ahead and apply this equation, velocity equals distance divided by time. So at this point, you do need a calculator. You can use your computer calculator. If you have an actual calculator, you can use that. If you have a phone calculator, you can use that. Or you can even Google the word calculator, and that will also pull up a calculator. Okay, so here's what we're going to do. We're going to take a look at this example of the dog. So this dog is going to walk to the right. Okay, so So the dog is going to walk to the right, which is in this direction, okay? And he's going to walk 1.5 meters, and he's going to do that in 3.6 seconds. So in order to figure out the velocity, we need to fill in this equation. So remember, velocity equals distance, that's our first blank here, divided by time, that's our second blank. So let's go ahead and annotate what we're looking at right here. So we see 1.5 meters. 1.5 meters is a distance. Okay, so remember, distance is measured in meters. Distance is how far it is from A to B. So he walks 1.5 meters, that's our distance. Now, he does this in 3.6 seconds. Seconds, you should know by now, seconds is a measurement of time. So when we fill this in, distance goes in the first blank, time goes in the second blank, according to our equation over here, distance divided by time. So I'm going to fill this in. This is 1.5 meters divided by 3.6 seconds. And now when I open up my calculator, let me go ahead and grab this. Okay, so I'm going to just Google calculator. So when I do this, I'm going to do, again, 1.5 meters divided by 3.6 seconds, and then press enter. Make sure you do it in the correct order. 1.5 meters, the distance goes first, and then press enter, and that's going to give me a measurement of 0.4 rounding up to 0.42. So this is my velocity, 0.42, and remember we talked about this on the previous slide. 0.4 velocity is going to be measured in meters per second in our class. Okay, now what's important to know here is we should also note that the dog was walking to the right. Okay, and if the dog's walking to the right, you'll notice that when you go to the right, that is actually the positive direction. So our answer here is the velocity was actually positive 0.42 meters per second, showing that he's moving 0.42 meters per second in the positive right direction. Now, how would our answer change if the dog walked to the left? Pause the video for a moment, think to yourself, how would it change if he went to the left? Okay, so if the dog was moving to the left, you'll notice that the left side of our number scale here is actually negative. So the left direction is actually the negative direction. So even if he was walking the same distance, the same time, and the speed was the same, still 0.42 meters per second, the velocity would change because now the velocity actually needs to be negative. Okay, so now he's moving in the negative direction and therefore velocity is negative. Again, make sure you have number 1 saved in your notes and we're going to go ahead and move on. Okay, so let's go ahead and try another one together. So a car travels forward 13 meters in 2.7 seconds. What is the car's velocity? So again, we have our equation right here, velocity equals distance divided by time. And we want to annotate this, figure out some important things. So first off, the car is traveling forward. So take a look at our scale right here. You'll see at our graph right here, you'll see that when you're going forward, that is considered the positive direction. So if he's going forward, I'm going to annotate this as our answer is probably going to be positive. So our velocity answer should be positive. 13 meters, this 13 meters right here should tell me my direction because remember, or sorry, my distance, because remember meters is a type of distance, a measurement of distance. And this 2.7 seconds is a measurement of time. Remember, seconds is a type of time. So now let's go ahead and fill in our equation here. So velocity equals distance, divided by time. And so velocity equals our distance, again, we annotated was 13 meters. 13 meters divided by our time, which is 2.7 seconds. 2.7 seconds. And now all we need to do is plug this into a calculator. So again, I'm going to go ahead and pull up my calculator here. And my distance again was 13 meters divided by my time, which is 2.7 seconds. So 13 divided by 2.7. I can make this smaller so you can still see this maybe. Here we go, 13 divided by 2.7. And I'll press enter, and that's going to give me a velocity of 4.8. And again, units for velocity is meters per second. Now, the very last thing we need to do before we confirm that this is our answer is look back at our annotations up here. And remember, the car was going forwards, so our answer should be a positive velocity. So based on that, your answer to number 2 should be positive 4.8 meters per second. None of these other ones make sense, can't be negative. And it's not going to be 35. That would have meant that you accidentally multiplied these instead of divided them. So our answer to number 2 in our notes is going to be positive 4.8 meters per second. Make sure you pause the video and save that. Make sure that you also actually answer positive 4.8. The answers do get randomized on your quiz, so make sure you read your answers carefully. Okay, so the last one that we want to practice for our velocity is this bird question. It's also in your notes. It's going to be number 3. So in this case, a bird flies down 42 meters in 1.9 seconds. What is the bird's velocity? Again, we're going to go ahead and annotate, plug it into our equation, do the calculation, and then come up with our answer. Okay, so very simple. We practice this many times. You'll become a master at this. So a bird flies downwards. Now taking a look at our graph over here, you can see that down is going to be our negative direction. So this is going to be important because in our answer should actually be negative. Okay, so the bird flies down, that's going to be negative. I'm going to annotate that will be negative. And he's moving 42 meters. Remember, meters is our distance. And he does that in 1.9 seconds. Remember, seconds tells me time. The time in which he did that. So now to calculate velocity, again, velocity equals distance divided by time. So I'm going to say V for velocity equals our distance divided by time and start filling those in. So V equals, what was our distance again? Our distance was 42 meters. 42 meters. Divided by our time, what was our time again? 1.9 seconds. And grab my calculator and actually do that calculation. Okay, so we've got 42 meters divided by 1.9 seconds. Again, just filled that in based on what I annotated up here, and now I'm just plugging it into the calculator. So 42 comes first, divided by 1.9. And what does that equal? That equals 22.1. Okay, so I have a velocity of 22.1 meters per second. Okay. But before I answer this, again, remember we do need to go back to our annotation. So a bird flies down. Remember that this downward direction means that my velocity is actually going in the negative direction. So my answer here should actually be negative 22.1 meters per second. Okay, make sure that makes sense to you. Make sure that you've done that calculation on your own. This is number 3 in your notes. Go ahead, make sure that is saved. And again, the answers are randomized, so make sure you read carefully so that you pick the correct one. Okay, so the next thing that we need to talk about is acceleration. So far we've talked about just speed and direction, which is velocity. But now acceleration is going to describe how velocity can actually change over time. Okay, so this has to do with this idea of forces. So a force is a push or a pull. And what forces do is forces will accelerate objects. So think about, for example, if you are standing next to your friend and then you push your friend, they are going to begin moving. So that means that they started at rest with no velocity, no speed, and then when you push them, they started moving, which made them faster. And so that's a change in velocity, and you accelerated your friend by pushing them. Okay, so forces will accelerate objects, make them move differently, change their velocity. So for example, a ball that's sitting on the ground is not going to move until there is a force applied. So until somebody kicks the ball or somebody pulls the ball, etc., someone drops the ball, a ball is not going to move. It's going to stay at 0 meters per second until you apply a force, at which point it begins to change its velocity. It begins to speed up, it begins to change direction, etc. So the important thing here, though, you can see over here in our examples, is that in science, oftentimes we think, like in everyday life, we think of acceleration as just getting faster. But in science, acceleration is actually defined as any change in velocity. And since velocity is both speed and direction, acceleration could be any change in speed or any change in direction. So take a look at these examples here. This person is accelerating because they're going from rest to moving much faster. So they're speeding up, their velocity is getting faster. So that's acceleration. However, the second example where this person's going really fast and then slowing down to a stop is still acceleration. Okay, because he's still changing his velocity. His velocity was fast and then his velocity was slow. So it's still an acceleration because his velocity changed. And then most importantly, this last one here is still a change in is still a change in velocity. And so this B here is still accelerating, or this fly. So this insect is accelerating because he's changing directions. So even though he might be flying at the same speed, the fact that he's changing directions a whole bunch and looping around, that change in direction still means that velocity is changing. Okay, so it's either speed or direction, whichever one changes, that still means that there's an acceleration, which should make sense. Think about every time you're in a car and you make a sharp turn, you'll feel that your body jerks. And anytime you feel your body jerk from one side to another, forwards or backwards, that shows that your car is accelerating. So whenever you turn left in a car, your body tries to move to the right. And so you can feel that the car is accelerating, even if you're going the same speed. Okay, this is number 4 in your notes. All right, so fill in the blank with the word change and only the word change. You should only be filling in the blanks with what you see in the red boxes. Okay, so let's break this down a little bit more. So positive acceleration is the one that we're most familiar with, most likely. So acceleration, again, is the change in velocity. So a positive acceleration means that you are changing in the positive direction, which means you are increasing your velocity. You're going from a smaller number to a bigger number. You're increasing velocity, making that positive. So this could be 2 different types of instances. This could mean that you're either starting motion or getting faster. So take a look over here. We've got this first example, which we're starting at 0 meters per second, and then we are beginning to move and ending at 4 meters per second. So in this case, this person goes from rest to moving, and since they're increasing their velocity going from 0 to 4, this would be a positive acceleration. This is positive. Same here with the second example. So this car is already moving at 7 meters per second, but then he speeds up to go to 9 meters per second. And since he's going from a smaller velocity to a larger velocity, that still means velocity is increasing, and that still means this is a positive acceleration. So in both of these cases, they're getting faster. They're starting to get faster, or they're already moving and getting faster anyways. Okay, so those are positive accelerations. Now, negative acceleration is going to be the opposite type of acceleration. So it's still acceleration because it's still a change in velocity, but negative acceleration means that your velocity actually decreases. So you either start getting slower or you are stopping your motion altogether. And so that's these last two examples right here. So take a look here. We have a car that's already moving at 6 meters per second. And then he sees the cops and he slows down to 3 meters per second. So in that case, he's slowing down, going from a bigger velocity to a smaller velocity. And since velocity is decreasing, getting smaller, this would be a negative acceleration. So these ones are positive, positive. This one, though, is negative. And same with this last example. If he's moving at 2 meters per second, and then suddenly there's a red light and he needs to stop, then he's going to stop and his velocity will go down to 0, meaning he's at rest. But again, he slowed down and his velocity decreased and went from a big number to a smaller number. And so that means that this is actually still negative acceleration. Okay, so you should be pretty comfortable now with both positive and negative. Another word for negative acceleration that you might hear in everyday life is deceleration. Okay, now zero acceleration is a tricky one. So again, acceleration means a rate of change in velocity of an object. Now, if there's zero acceleration, that means that there's no change in velocity, right? Because that means that you don't want this, right? So zero acceleration means that the velocity is unchanging. So the velocity does not change. Now, the one that's easiest to understand is if you're at rest and you stay at rest, right? So this car right here, he's not going anywhere until someone forces him to, meaning a force accelerates him, like the gas, okay? So he's staying at rest, which means that he's at 0 meters per second, and he stays at 0 meters per second. So he starts at 0, ends at 0, meaning that his velocity does not change. Okay, so that's zero acceleration. However, the trickier one is this one, where you can actually still have zero acceleration if you are still maintaining the same motion. So this is like, again, we talked about in a car. In a car, you feel like you're accelerating when you feel your body jerk, right? So that means when you speed up fast, slow down quickly, when you turn very quickly. All of those are examples of acceleration. However, most of the time, you don't actually feel any acceleration in the car because you're not accelerating. So for example, when you're on the highway going at 60 miles per hour for the entire time and you're on cruise control, your body does not jerk around because your body is not experiencing acceleration. There's zero acceleration because you are maintaining the same speed. So when you maintain the same motion, both speed and direction, that is still zero acceleration because your velocity is still not changing. Okay, so this car is going to keep going until something stops him. So for example, if he's going positive 30 meters per second and then continues moving at positive 30 meters per second, that is no change in velocity. And therefore, this means that this is zero acceleration. Zero acceleration. Okay, so again, that's a little bit hard to wrap your mind around sometimes because you can still be moving without accelerating. Okay, so zero acceleration even while he's moving. Awesome, so at this point, go ahead and try to test yourself, pause the video, try to test yourself and match these up on your own, and then we'll come back together and I will give you the answers to these. All right, so let's go ahead and go over this. So we have some different types of motion on the left, and then we have the type of acceleration that they could be on the right. Okay, so positive acceleration, let's actually talk about this. So stopping motion. Stopping motion means that you're moving and then you go down to rest, which means that your velocity is decreasing, right? It means that you have maybe 3 meters per second and then you go down to 0, which means it's decreasing. And anytime we have velocity decreasing, that's going to be a negative acceleration, right? Or you could call it deceleration. Now, on the other hand, if you're getting faster, let's say you're moving and then suddenly you need to speed up for some reason, right? Getting faster means that your velocity is increasing. And so an increase in velocity would be a positive acceleration, right? Now, if you're maintaining the same motion, remember we talked about this one, this is a tricky one. Let's say that you're driving at 60 miles per hour in a straight line, and you keep on driving at 60 miles per hour in a straight line. Again, you are not changing your motion, right? You're maintaining your motion, and since there's no change in velocity, that is actually zero acceleration. There is no acceleration because you're just staying the same. I'm going to change colors to make sure that this is clear. Okay. Now, if you're starting your motion again is starting at rest and then getting faster, which is an increase in velocity. So that's again positive. Getting slower means that your velocity is decreasing. You're moving, but then you slow it down, and that's going to be negative. Again, a decrease is negative. And then staying at rest. This one's easy, right? You're at 0 meters per second. You stay at 0 meters per second. There's no change in velocity, and so this one is actually also zero acceleration. Okay, this is number 5 in your notes. Pause your videos and make sure that you answer this in number 5 and then continue playing the video. Okay, so now we need to talk about how to calculate acceleration. So we need a few things in order to calculate acceleration. We need to know the initial velocity of the object, the final velocity of the object, and the amount of time it took to go from the initial to final velocity. So that should make sense, right? When you think about this idea of really good cars going from 0 to 100 miles per hour in, or I guess 0 to 60 is it, right? 0 to 60 in 3 seconds, right? What they're saying is they're going from an initial velocity of 0 miles per hour to 60 miles per hour in 3 seconds. Those are all things that you need to know in order to know acceleration, whether or not it's a good car with a good acceleration or a bad car with a poor acceleration. So here's what the equation actually looks like. So the equation equals acceleration equals, first you do velocity. So this is first one. First you do the final velocity minus the initial velocity. And then step 2 is you divide by time. So remember, whatever goes in parentheses goes first. So you first do final minus initial, and then outside of parentheses, then you divide by time. Now our answer is going to be an acceleration. So the units for acceleration are meters per second squared. Okay, this is important. So far for all of our velocities, we've been talking about meters per second, but for acceleration, it's actually squared. So make sure that you understand this. Acceleration units, your answer should be meters per second squared. That's what this little 2 means. Okay? All right, so this is actually, before we do this calculation, make sure you pause the video. Number 6 in your notes, you should fill in the blank with acceleration. And number 7 in your notes, you should fill the blank in with the word units. Go ahead and do that, and then continue playing once you're ready. Okay, so here's our example. A car is moving at 6 meters per second, and then he steps on the gas for 2.1 seconds until he's moving at 9 meters per second. So we're going to go ahead and figure out what is his acceleration. So take a look at, let's go ahead and annotate this. So first, he's moving at 6 meters per second, which that means that that is his initial or starting velocity. So I'm going to mark this as V initial. Okay, his starting velocity is 6 meters per second. I'm also going to mark it down here. So he starts off at moving at a speed of 6 meters per second, or a velocity of 6 meters per second. Then he steps on the gas for 2.1 seconds. Remember, seconds tells me time, until he's finally moving at 9 meters per second. So since he ends at 9 meters per second, this is our final or ending velocity. So V final is 9 meters per second. So I could draw that down here, 9 meters per second. And again, this happens in a time of 2.1 seconds. So let's go ahead and fill in our equation. So A equals, in the first blank, we need V final. So this right here is V final, VF. And our final velocity, we said, was 9 meters per second. So 9 meters per second. Minus our initial velocity, that goes in the next blank. So V initial. And that, again, was 6 meters per second. And dividing that by our time here is 2.1 seconds, right? Because remember, this last blank should be time, so this is 2.1 seconds, okay? Now remember, we need to do what's in the parentheses first. So first we need to do 9 minus 6, which hopefully you know 9 minus 6 equals 3, okay? And we're still going to divide by 2.1 seconds. Okay, still divide by 2.1. So at this point, I can grab my calculator because that's a little bit harder to do mental math. So I'm going to do 3 divided by 2.1, exactly as I see right here. And 3 divided by 2.1 is going to give me an answer of 1.4. Okay, so we can see 1.4 right here. Okay, so 1.4. Now again, the units here, you need to include units on your answer, is going to be meters per second squared. Okay, so the answer here is 1.4 meters per second squared. Okay, let's go ahead and do another one, and this next one is going to actually go into your notes. So this time, a car is moving at 10 meters per second, and it slows down to 2 meters per second in 6.5 seconds. What is the car's acceleration? So let's annotate this. So he's moving at 10 meters per second. That means that this is the speed he's starting at, and so this is our V initial, our initial velocity. V initial, starting velocity. And then he's going to slow down to 2 meters per second, and 2 meters per second is our final velocity, right? Because this is what he's ending at, so V final. And he does this in 6.5 seconds. Again, seconds gives me time. Okay, so take a look over here. We've got our equation. So let's go ahead and start filling this out. So V final, we said was 2 meters per second. V initial, we said was 10. So I'm going to fill in the blank here with the number 10. And divide it by the time, which we said was 6.5 seconds. So I'm going to divide by 6.5. Okay, so we have our equation filled out. Now again, we do what's in parentheses first. So we're going to do 2 minus 10. Now remember that this is actually going to end up being a negative answer. When you do 2 minus 10, okay, that's doing a small positive number and then subtracting it by a really big number. And so you're going to actually end up with negative 8. So 2 minus 10 gives me negative 8. And then I'm going to still divide that by 6.5 seconds. So now let's go ahead, take a look at our calculator. Okay, so 2 minus 10 gave me negative 8. Now I'm going to divide that negative 8 by 6.5. And that's going to give me an answer of negative 1.2. Negative 1.2. Now you might be wondering, why is your answer negative? Well, think back to what we talked about with negative accelerations. We said negative accelerations mean we're either stopping our motion or getting slower. And if we look at our question here, it says right here that this car is slowing down. So since we're starting at a fast 10 meters per second and then slowing down to a 2 meters per second, our velocity decreases, and that's why our acceleration is actually negative. Now, last thing that we need is that you actually see 2 right over here, negative 1.2s, and the only difference between them is the units. So remember, units for acceleration are going to be meters per second squared. So the only correct answer here is actually negative 1.2 meters per second squared. So make sure in your notes you answered this correctly and read carefully. Make sure you choose the one that has the squared on its units. Go ahead, save that, and then continue playing the video. All right, so last thing that we need to do is just to review these different terms. So go ahead, pause the video, take a moment to try to match these up on your own, and then continue playing, and we will get the correct answers together. Okay, so looking at this, a force, remember a force is a push or a pull. Okay, and motion is going to describe how an object moves from one position to another. Velocity is including both speed and direction. Remember, velocity can be positive direction or negative direction, or it could be positive or negative depending on the direction. And then acceleration, remember, is the rate of change in velocity. Remember, it means velocity does need to be changing. It needs to be getting faster, it needs to be getting slower, or we don't really talk about this one as much, but it could mean that it's also changing directions. Okay, make sure you pause the video, make sure that you answer number 9 in your notes. Again, the answers are randomized, so make sure that you are reading carefully. All right, so at this point, we should be able to understand the differences between speed and velocity, define and calculate velocity, as well as calculate and describe the effects of acceleration on velocity. So what I want you to do is make sure that you rate your understanding of today's objectives. Okay, think if you're very confused, still need some help, feeling pretty good or awesome. Hopefully you're over here on the right, but if you do find that you're over here on the left, make sure you're coming to support sessions or that you're texting or emailing or calling me to let me know that you still need help on some of these objectives. And then the last thing is, before you submit your notes, make sure you review everything, take a look at everything, and think about what's one thing that you learned today, and try to remember that, try to solidify that in your brain. So pause the video for a moment, take a look at your notes, what's one thing that you learned or reviewed today that's important, and then continue playing. Awesome. And at this point, you should be able to, sorry, this should say 2A. You should be able to submit your 2A notes. Make sure that you fully submit them. It's going to ask you to confirm your submission, so always submit twice. All right, thanks so much, everyone, and that is everything for today.